Here is 1.8 part 2 of our movie. The definition is horizontal line test. A function f has an inverse if and only if no horizontal line intersects the graph. We call this passing, and it has a one-to-one property. So the two examples I don't need you to write down. You'll just verbally tell me if it passes or doesn't pass. So first example. The shape is a V. Does that one pass the vertical line, the horizontal line test? No, it doesn't pass. It fails the horizontal line test. It hits twice. So this function would not have an inverse. Over here, second example, the blue line. Does it pass the horizontal line test? Yes or no?
Yes.
Yes. It passes the horizontal line test, so it could go out and find the inverse. So what I want you to take from this slide is just what the definition of a horizontal line test is. It cannot hit more than once, and it helps us to identify if a relation, if a function has a inverse. Steps to finding the inverse of a function. Write these down. We did this in Algebra 2. It might sound familiar to you, but what we're going to move on to next is doing an example of one of these. To be able to use these 4 steps, you must first know that the function passes a horizontal line test. It is one-to-one. If that's the case, we go through these 4 steps. And we do this when we have an equation, not a relation, not a set of order pairs. If they just give you a set of order pairs, you just flip-flop all those x's and y's. So step 1 is to replace the function notation with the letter y. Step 2 is to flip-flop the x and y in the equation. Every x becomes a y, every y becomes an x. Step 3 is to solve that equation for y. And then last step is to replace that y with f inverse. So it'll be f inverse of x. If we have the letter g, then to say g inverse of x. And again, you can only do these 4 steps if it passes the horizontal line test. It's one-to-one. So give me some time to finish writing that up. Here's an example. Here's a function, f of x equals 4x minus 5. I do recommend that you go through these steps with me on this example. I have one more on the next slide that we'll just kind of watch and you'll help me with. So we give you f of x equals 4x minus 5. Do you know what the parent function of this function is? What does it look like? What's the parent function? Is it a parabola? Is it a v? It's a line. It's a linear function. So the linear function says its y-intercept is -5 and its slope is 4. Passes a horizontal line test, so I can continue. It does exist. There is an inverse exists for this function. It passes the horizontal line test. It's one-to-one. So step 1, we're going to go ahead and do that first. So step 1 is to replace the f of x notation with the letter y. Step 2 is to interchange the x and the y. So this now becomes an x. This now becomes a y. Step 3 is to solve this equation now for y. So what will be our first step? Add 5. So we add 5 to both sides. Next step, divide by 4. Now I'm just going to break that parentheses up into 2 parts. So I'm going to divide both the x and the 5 by 4. Now I always like to write my y first. Then x over 4 is the same thing as 1/4 x. And then plus 5/4. So again, we have another line in slope-intercept form. The last step is to replace that y with what? Yep. So we're going to replace the y with f inverse of x. Now we have the inverse function. If I go out and graph those 2 lines, they're going to be symmetric about the line y equals x, if we take the time to do it, but we're not going to. So how you find an inverse function is these 4 steps. Do you remember doing this in Algebra 2? Okay. Next example. Would you like to do this example? Okay, so let's just have you maybe watch the example this time, and you'll help me along, and you'll put your pencils down. So find the inverse of this function. Again, it's another linear function. It passes a horizontal line test. So step 1, replace the function, the f of x, with y. What's step 2? Step 2. Switch. Very good. Step 2. Switch the x and y. This now becomes an x. And that now becomes a y. Step 3. What's step 3? Solve for y. So how do I get the y by itself? Multiply both sides by 2, good. So this becomes 2x, 5 minus 3y. My 2 is now gone from the denominator. Next step. Subtract 5. Next step. Divide by -3. And I'm going to split up the fraction. Write my y first. -3, -2/3 x, plus -5 divided by -3 is 5/3. So now I've solved the equation for y. What's the last step? Rewrite it as the inverse of x. If I go on and graph the original function and this inverse function on the same plane, they will be symmetric about the line y equals x. Stop recording there and pick back up.